Perfect. Hi. So thank you everybody for having me. Can you hear me? Okay, good. This is very new to me. So yeah, I just want to first extend a huge thank you to all the wonderful women who put this on. This is a great opportunity, as well as the sponsors who made this all possible. And I'd also like to congratulate the other finalists. Their projects were really interesting. I'm glad I got to hear more about them. And yeah, I'm here to present to you my cross probability tool. But before I get into that, I would like to give you a bit of background on myself so you can get to know me a bit more. So my name's Caitlan. I'm a fourth year engineering student at the University of Waterloo, where I'm in their co-op program. So I've been lucky enough to carry out several data science co-ops. My latest one was at a fintech company in Toronto called Wealthsimple, but I also had the privilege of working at Megan Chayka's company, Stathletes, about a year ago. I was doing some Shiny app development there, mostly pertaining to player stats. So working with 360 data was definitely a new challenge for me. And working at Stathletes was awesome because, as you can see, I'm a big hockey fan. I've played since I was young. And I also played soccer since I was a little kid, and I still do to this day. So that was helpful in kind of navigating this project and everything, having that baseline understanding. And I think this photo here just proves that I'm qualified to present to you today on the matter. Okay, so here's the brief agenda for today. So I'll go over my motivation for the project, my implementation, and then the extensions. So there's a lot to fit in, but I'll do my best to get it all out. So yeah, I almost spent too much time landing on the idea I wanted to work on. I did a lot of research on, areas of research previously done in the game of soccer, and I was really intrigued by these two papers. One was a passing lane model by a previous StatsBomb conference, and then also a passing lane model from an NHL analytics conference. So these were kind of like my jumping off point. My end project didn't end up much like either of them, but I knew I wanted to kind of look at decision making, but also passing. And from there, I narrowed my scope to look at cross passes because I didn't see too much research in that area. So I thought it'd be a bit of a different view of passing. So with that, let me talk about cross passes. So if we, read papers and just watch the game of soccer, we do see that many crosses do lead to turnovers. And I even came across this article where it stated like teams should, avoid these types of passes. They're highly ineffective. They don't see the reason why teams are still using these. But in kind of on the other side of things, we are seeing top teams start to play much wider games where these cross passes are more effective in that case. And then also we see that these, oops, I'm going far ahead. There we go. Sorry. We see that if these teams instead hone in on their cross opportunities, then they will, generate more scoring opportunities as a result. They get the opponents turning, they get the ball in front of the net. So they do lead to dangerous scoring opportunities. So now if we look at the StatsBomb data, we do see that there are far more incompleted passes than completed passes. And we see about a 33% success rate there. But with those completed crosses, we see that 44% of them led to a direct shot opportunity, and 10% of those shots result in goals. And for context, about 9% of all shots on net lead to goals. So it just goes to show that the shots off of these cross passes are just as effective and dangerous of scoring opportunities as any other shot. So if teams, start looking into more dialing in their cross passes, then they'll, as a result, hopefully convert to more goals. So I'll flash forward to my kind of end solution. I knew I wanted to build a probability model for the success of a cross. But as I was kind of building that out, I kind of thought like, well, it's one thing to have the probability, but what do we gain from that cross being made? And that's where I came up with the idea of using XG as a reward metric. So that just and I chose XG because, these cross passes are placed in front of the net. So they lead to direct scoring opportunities as a result. So that's kind of why I landed on XG. And yeah, if you look at this image here, oh my goodness, sorry. If you look at this image here, we see that we have all these sections, and it highlights the optimal cross location as well as the probability associated with it and the resultant XG. And I'll go into more detail on how I implemented all this. And you'll maybe be able to see from here, but there are some zones that have a probability of 0. And I just made that simplification because there's no support in those zones, so no teammates in there. And obviously this might be a bit naive because, there's the opportunity for players to run into the zone to pick up that ball. but for the sake of the project, I just disregarded them. So now I'll talk about how I implemented all of this. So first I partitioned the field as such, and I did this because I made the assumption that crosses are made to space rather than to a direct recipient, because if you watch these passes being made, your teammates are primarily running onto the ball. And kind of how I saw it was, the person making the cross knows where they want to place it, and then it's up to your teammates to really make sure that they connect with that ball. So that was kind of justifying that assumption. And then if we look at where crosses have been made in the past, we see that they primarily come from the outer flanks and are placed directly in front of the net. And so that kind of got me thinking, like, the fact that there's so many incompleted crosses and they are primarily being placed right in front of the net, maybe there is a more productive location to be placing these crosses rather than right in front of the net, while still maintaining a good scoring opportunity. So how I processed the data was I generated freeze frames for all the player locations. For each cross event, I then encoded those locations to match the zones I just went over. And then I also calculated some additional features. So one being the pressure on the person making the ball or making the pass. And I defined that to be 3 yards, and that pressure radius came directly from a StatsBomb article. So I just kind of followed what their reasoning was there. And then I also calculated the number of opponents and teammates in the end zones. And then, of course, I'm given information on the outcome of the cross and the height of the cross. But with that being said, if we look at this image here, we see that primarily these cross passes are made high in the air. So then, there are some lower passes made, but they're primarily made high in the air. So I made the assumption that all these passes are made high in the air. And that way we don't need to model the probability of interception in any section between the person making the cross and the end location. So that was kind of the justification there. So now how I modeled this, I tested out a few different machine learning models, such as gradient boosted trees, naive Bayes, and logistic regression. And I did land on using logistic regression, one, because it fit the data pretty well, but also, if I'm being honest, I am a kind of a newbie when it comes to machine learning. So I felt if I knew how the model worked well enough, I'd have the best chance of fine tuning it and really dialing in the model. So that was kind of another leading factor for why I chose this model. And then we kind of saw earlier that there is a slight imbalance in the data. And when I tried balancing the data, it improved performance. So I used the undersampling technique to balance the data, and that upped the performance a bit more there. And then, of course, I applied cross-validation and parameter tuning to really hone in the final model, keeping in mind specifically the precision and recall of the model, because sometimes I would get an abnormally high accuracy, but the precision and recall would be quite poor. So I wanted to make sure that, I wasn't being misled by a high accuracy, and that the precision and recall were still sufficient enough. That was essentially my process in modeling. And then it looks like the formatting got a bit messed up, but that's XG. So this is how I modeled the XG value now. This kind of came along a bit later in the project. And I wanted it to kind of be modeled similarly to the cross probability, but given the time constraint left and also just the difficulty and nature of this problem, I decided to instead rely on conditional probability just to keep it simple. And, I wanted to devote time to making a UI rather than like another machine learning model. So that's why I chose conditional probability. And that conditional probability looks like this. It's the probability of a goal given the number of opponents in that zone. So it kind of gets a nice generalized XG value for each of the zones based on the number of opponents in that zone. So now I have this like probability of success, I have this reward metric, and I wanted a way to kind of wrap it up into a single recommendation. But I also thought it'd be pretty interesting to play into coaching style somehow, because growing up, I've been coached by a lot of different people, and I realized that no two coaching styles are alike. So with that, I kind of wanted to find a way to play into that. And that's where I came up with the idea of risk tolerance, because you may have some coaches that are a bit more conservative. They want to maintain possession, and, the shots will come as a result, versus coaches that are a bit more bold and risk-taking, and they want to, generate large and dangerous scoring opportunities, no matter how unlikely they are. So with that risk tolerance value, I was able to then wrap this up into a simple optimization problem. And how that looks is essentially for each zone, I calculate the probability of a successful cross plus the risk tolerance times the expected goal value. And then there's also an additional penalty factor in there. And I applied the risk weight and that penalty factor to the XG because, as you can assume, the riskiest crosses do often reap the greatest rewards. So I needed a way to kind of mellow out those extreme XGs and balance it more to the cross probability, as well, just allowing that XG not to dominate the optimization in that way. And so I essentially loop over each possible end zone and I select the maximum one. So now looking at the UI, this was built using Streamlit in Python. So very, very great package. And it's a fairly simple UI. So the user can go in, they can select the match they want to look at. They can select the team from that match they want to look at. And then the crosses are labeled by the player that made the cross and the timestamp. And then, of course, they can toggle their risk tolerance. And I kind of envision this tool to be used for coaches to, one, look at the decision making of the players. So for example, if this cross was actually made to the top of the box in the game, but the model is suggesting it's made to the center of the box, then, they can kind of evaluate that player's decision making in that way. But it can also help the team learn more about these cross passes, given that we don't see a huge emphasis on these types of passes being made, or really like caring to dial them in. So this can also help the coach kind of learn, what their playing style with this type of pass should be. So here's an example of a risk-averse coach. So, they want to maintain possession, so that they dial down their risk tolerance to be like 0.25, and the optimal zone selected is this close one. And then if we have more of a risk-taking coach, they want potential high rewards, then they'll dial up their risk tolerance and they will be suggested to cross it to this middle box. So that's essentially how the UI works. It's fairly simple and easy to work through. And now I'll just go over some potential next steps I have in mind if this model were to be further developed. So one, I kind of touched on it, is more robust modeling. So maybe there's better classification models to fit the cross probability, as well as building out a good sufficient XG model using machine learning. That would probably be beneficial. And then also looking into crosses made to specific recipients. Maybe a coach has a player that's really good at heading the ball in the net, and they kind of want to see how well they're able to do that and kind of their likelihood of connecting with that cross. And with that, you would probably need to model player movement then, because these passes are relatively long. So there is the time for the player to move in that span of time that the freeze frames can't capture. And with those two thoughts in mind, though, that's kind of why I opted to stick to zones and look like crosses made to space. One lessens the effect of player movement, and also it can kind of act as a way to know where you should be putting these key players rather than, where the ball should be, rather than looking at how the cross should be made to those players, rather get those players in the location of where the cross should be. And then lastly, looking at different reward metrics. So for example, if we look at a cross made to the top of the box, maybe coaches aren't going to want their players firing shots off from that far out. So expected threat may be a better metric in that case. And, you could kind of work in a weighted sum into that optimization based on, which metric a coach values more for each situation. And yeah, that's kind of what I have in mind for future work. And I'd just like to thank you all for listening. And you can follow me on LinkedIn if you'd like. And thank you. If I sounded nervous, it's because I was.
Hi. I really thought you did a great job with how you created your model and how you selected your features. I wanted to know what you would think, because the idea of when you would execute a cross probably has to do with the in-game situation as well. And so I'm curious how you might incorporate either score, so tied, down one, up one, that sort of thing, and time of game into a model like this, because then, those situations are going to play a lot in how you decide whether you're going to do something like this or not.
Yeah, you're right. That's actually very interesting, because you're right. If we're later in the game and you're down a couple goals, you're going to want to firing off more crosses to get the ball in front of the net. So that could probably be an interesting feature in that case. And likewise, if you're up a few goals, you're not going to be making those riskier crosses. You're going to maintain your possession. So yeah, definitely time of game and score, yeah, could be played into the model in that way. That's an interesting suggestion. I don't know if there was a question tacked onto that, but yeah. Oh, how? Yeah, great question how I would do that. You know what? I'd have to think on it a bit more. I'll come back to you on that one. But yeah, I like we're given the timestamps of the crosses and that sort of thing. So that also plays into it. I don't know if it would necessarily though play into the fact of the likelihood of that cross being complete, because it's just a matter of now looking into when and if those crosses should be made. So that can kind of be more on the UI side of things, where we kind of see yeah, like if it's recommended that that cross should be made at that point. So that's kind of, I guess, a thought on that.
Oh, hey, my name is Tarush. I had a question in a similar vein. If you have, like, I was kind of curious on how transferable these would be between different leagues and different pitch sizes, especially because I know, like Tottenham Hotspur had a really short field as in comparison to some of the other Premier League teams. So would that kind of change the way that you approach crosses? And then I don't know about different leagues, but maybe if like the college pitch is different than the pro pitch, then that might also be a different variable. Just curious about that.
For sure, yeah. And so to preface this, I don't have too broad of a scope of high level soccer, but from what, like, in terms of the model, it wouldn't really affect it too much. You know, it would just, the coordinates would be altered and that sort of thing. That I feel would be, I feel like a more like a stylistic choice of the coach, because you know, if you are on a shorter pitch, maybe these cross passes, well, they still would be effective, but yeah, I'm not too sure how it would play into the model. It would definitely like easily fit into the model, but rather the effect of them, I'm not too sure. Something I would have to think about.
Hi, so it's a really great presentation. I really liked it, and the cross aspect is great. I was wondering, like, you're breaking up the sections. You could kind of go like all the way like super granular and look at all the little spaces, or you could just say cross is good or bad. Did you play with like how many sections you can have and how that kind of changes your model and how it might work?
Yeah, so when I first like started like coming up with the zones, I had it quite granular, and I realized that would be very computationally complex and also maybe not so much realistic, because you know the 18-yard box, if you think of how fast these players are running, they can travel that distance really quick. So that's why I thought like the grain of these sections that I chose seemed sufficient enough, so that one, there was a bit of margin for the player making the cross to place the ball there, but also not so granular that it's like just like a little square, in which case it would be looking at like direct passes would be more sufficient than like looking at like a little section of the box. I don't know if that answers your question.
Hi, I also was really fascinated by this project. It's really interesting. And I really like your focus on the risk tolerance aspect. That really like tied it all together for me. I was like, that's super cool. I'm curious. So you were talking about with the UI, the ability to kind of look at specific teams. And then you mentioned as an extension that you might want to look at even like player specifics, which I thought was really interesting. And I think could be an interesting defensive tool to like look at a team you're about to play or something like that. And I'm curious, like with the data that you had, how extensible do you feel like this project is in that direction, or how feasible do you think it would be really difficult to make that extension, or is it something you think is like within reach?
Yeah, good question. So I, you know, haven't dove too deep in like the technicalities of how that would be modeled out, but in terms of that, it would be more so looking at, well, it is still like reliant on where that player is. So I'm not exactly sure how like beneficial it would be to look at that. But in terms of yeah, one, it wasn't really possible to do that just given the scope of the data. One, there's not very many cross passes, so data was already a limitation. But then looking at these certain players and their like received passes, there was very few. So that definitely would be more of like a blue sky feature, because there's not enough data, at least in the data I had. But yeah, I thought it would be cool just looking at what like what players are better at completing those crosses and that such a thing. And it'd be kind of interesting to see like which two players, like one making the cross and one receiving it, like which two kind of pair well together in that sense. That could be also an interesting thing to look at in that case.
I have a quick question.
Yes.
I'm over here.
Oh, hi.
In the beginning, when you were talking about the articles that you read, you stated that it wasn't very useful to use cross pass, right? Or did you say?
Oh yeah, the author that wrote the paper suggested that these passes are so ineffective that teams should stop making them.
Right. So what made you continue doing the project on CrossPass, knowing that it's not necessarily the best thing to use in the sport? What made you say like, this is something that I want to continue to do, even though like they shouldn't be doing it? Was it like the intrigue that it was something that they continue to do anyway?
Yeah, so these cross passes are still being made quite often, but also the fact that like players are inevitably going to end up with the ball very deep in the corner. I don't know if I said that in my presentation. I meant to. They're going to end up with the ball deep in the corner, and so like cross passes are a great way to get the ball in front of the net quickly, and it's just a fact of the game. They do still come. It's just a matter of, you know, if coaches want to keep doing them and that sort of thing. And I thought there also probably wasn't a huge emphasis on these types of passes, like say in practices and that sort of thing. So I thought there was opportunity for these types of passes to be like honed in more by teams and that sort of thing. So that's kind of why I chose to go with it. Thank you.